My name is Vutlhari Rikhotso, which is Xitsonga, not Venda. But all of you can call me VT. Everyone else does. If you're here, you might recognize me from my dank tweets, talking about all things programming and how developers are great. When I'm not throwing out great tweets, my day job, I'm a principal consultant at Demon. Demon is a tech consultancy in the UK. Principal is a very fancy sounding term so that we can get to the guys with the money. Consultant is developer with extra steps. The developer likes to talk a lot, right? When I'm not doing that, I host two podcasts. One, ZA Tech Radio, with two of my friends who I met on Twitter. And the other one is the Demon Podcast, because I'm a consultant. So I have three disclaimers before the start of this talk. Number one, this talk is not about JavaScript, I swear. It might seem like it at some point, but it's not. Let's just keep that in mind. This talk is not about JavaScript. Number two is, I know that readability is more important than lines of code. We all read Medium posts. Number three, this talk is not even about deleting code. What? Cool. So look, about 3 years ago, we had COVID and Clubhouse was invented. We're all bored sitting at home. So I became very active on Twitter, spewing my very opinions that are my own and not that of my employer. And people started interacting with me. I think when I started, at the time, I had about 200 followers on Twitter. So I was tweeting into the void. People started following me. And now people started caring about my actual opinion. And people started inviting me to places to talk, like BBD, their mistake. My poor wife has to endure me correcting strangers on the internet, telling them that Jan was, in fact, at some point better than NPM, but JavaScript sucks, so no one cares. This talk is not about JavaScript. But a necessity was born out of my activity on the internet. Because people invited me to things, people wanted to know where my GitHub is. I don't know, my GitHub is empty. What my Twitter is, Blue Sky, Nostra, Instagram, LinkedIn. So I had to create a website. And like every good citizen of the internet, I bought a domain. It's the easy part, right? Go in, put in your credit card information, buy a domain. I bought one. Then step two was the most difficult. Step two was the most difficult part. Choosing a JavaScript framework. There's a new one every 24 hours. So I knew that I was stuck with my choice, right? Because I have to defend it on Twitter and why it's the one true framework. So I came up with a simple experiment. Number one was create two projects. I narrowed it down. Most of my friends write Vue and React. So on the podcast, Sihle writes React, Stu writes Vue, right? So those are most of my friends. So I limited it to those two. And then because I'm a consultant and I have to do things that seem complicated, I came up with 3 commands that I was going to run on the node modules, which we, of course, don't check into source control. The first command was to calculate the amount of disk usage because space is limited. We all want to use MacBooks, but we can only afford the ones with 128 gigs on them. So space is important. Number 2, we wanted to count the number of files and directories just to know how much I'm opting into when I choose that framework. And number 3, I installed something called clock, which counts the number of lines of code. Remember, I know that readability is more important than lines of code. Yeah. And then I did what we all do, right? I created a React. It's not really React anymore because Create React app has been removed from the docs. So I created a Next app, but it's basically React, right? Because it's Vercel and they're kind of like part of the React core team somewhere. And then a Vue project. And what I did is like everyone else, I enabled all the options. Who doesn't want Tailwind in the app and ESLint and Prettier and TypeScript? TypeScript is great, right? And we all hate DHH. So yeah, enable TypeScript. Then I ran my commands. First on the next app. First space, right? Node modules. The next app took 297 megabytes space on my computer. That's significant because I only have 128 gigabytes, right? And most of it is the operating system. That's fine. Files, directories, I'm like, how much of this can I go into? So Next.js came in at 295 files and directories. And then our most important measure, lines of code. Next.js came at a whopping 1.9 million lines of code. This is just the JavaScript and TypeScript. I ignored everything else. And then, like, cool, that's great. Let's go to the next one. Vue.js. Vue.js took 199 megabytes. It had 470 files and directories, and it came in at just over 2 million lines of code, right? That might not mean anything to you, especially if you're new to programming, but that's significantly more lines of code than it took for the software that launched people into orbit, including the autopilot software on it, right? For me to create a website with links to my Twitter and my GitHub, right? If that doesn't translate, oh, you know what, maybe Space Shuttle just didn't need that much code. MS-DOS doesn't even register on the graph because that was only 4,000 lines of code. But other operating systems like Windows NT and Windows 3.1 came in at like just about the same lines of code. But you know, maybe lines of code, again, don't mean anything to you, but maybe you like Game of Thrones, so this will translate. 2 million lines of code, if printed, equals to 36,000 pages of text, right? That is 7 times the entire works, A Song of Ice and Fire by George R.R. Martin. I know Game of Thrones is disappointing, but so is this amount of lines of code. Again, that's more than was needed to run the space shuttle, a pacemaker, or even the entire game engine of Quake 3, right? That's absurd. At least it is in my view. But wait, there's more. It doesn't end there, right? You remember I counted the number of directories and files? I went in, I recently installed NeoVim, so I was practicing and navigating directories through there. And I found this amazing library, Bullbase, a 1-file, 2-function library. One function named truefunc, the other named falsefunc. Guess what they return? True and false. What? That is somewhere in the Vue.js code. There's a lot of examples like this. And when I wrote this slide for the first time, I said, this is bloat. But I knew there were probably a lot of JavaScript fans here, so like I changed it to this looks like bloat. Again, remember, this talk's not about JavaScript. But to understand why I think this looks like bloat, we need to understand the CPU, the central processing unit. I know this is not going to be some history of computers, maybe a little bit. You see, the CPU is made of billions of transistors. And until recently, the transistor count on a CPU would double every 18 months, right? More transistors means faster and more powerful computers. See, this observation was made by Moore, Gordon Moore, and it has held true for more than 55 years. Held true, because if you look at the graph, you can see that it's declining. 2020, COVID, Moore's Law coming to an end, conspiracy. This means that this trend that follows Moore's Law that says these chips would get smaller and the transistor count would double has started to slow down. That doesn't mean they won't get smaller anymore. I was very disappointed when I was watching the Apple event the other day and they introduced a CPU with 19 billion transistors when my slides said there were 5.2 billion, and they just changed that like 2 days ago or something. But it does mean that it gets far more expensive, and that's why MacBooks and iPhones are so expensive. When you look at it, computers over time have gotten smaller and way more powerful. In the keynote, Lucky said that this thing that you have on your phone is way more powerful than things we had in the past. This is because Moore's law should mean faster, more powerful computers. But do you ever get the sneaky feeling that that's not the case? That if you had a Pentium 2 in 2000 and something, and you pressed on the key on your keyboard, that over time, the amount of time, the latency it takes for the key to appear on your computer has slowed down. It's because it has, right? But why? Because Moore's law has an evil stepsister, With's law. You see, Niklaus With observed that software speeds have an inverse relationship with hardware speeds, meaning that as our hardware gets faster, every 18 months, our software gets slower at an even faster rate. What? Well, if you don't believe me, there's even a saying that says that what Intel giveth, Microsoft taketh away, right? I've replaced Microsoft with programmers because I like Rory, right? So let's look at why the slowing down of software happens. It happens for several reasons, many reasons. I actually cut down one out of here because I didn't like the number 5, but I chose 4, right? Number 1, surprise, surprise, is because it can. What do I mean by that? Because it can, right? Because it can. Because if you wrote a program, well, for a very long time, until recently, if you wrote a program and left it unchanged, it would actually get faster over time. Every 18 months, it would just be twice as fast without you doing anything, right? So terms like DX started to come about, developer experience, because that's more important than the speeds that people have. You load a simple recipe website and 10 megabytes of JavaScript is loaded on your front end. Number 2, complexity. What do I mean by that? Well, look, the software that we run on our computers, on our phones, on our fridges, it's not trivial anymore, right? To the point that Jamie Zawinski said that our software expands until it can read mail, right? That's maybe not the case anymore, right? Twitter doesn't read mail. Instagram doesn't read mail, really. Who knows? Maybe Zuck does read your mail. But who remembers Instagram, the photo sharing app? Right? Good times, right? Guess what it does now? It has messages. So does Twitter. So does LinkedIn, a form of mail. And I would like to update that saying and to say that software is complex because software expands to eventually have whatever is cool at the moment. Right? Remember, does anyone know VS Code stories? It's real. Number 3, and maybe most importantly, because a lot of us are either training software developers to become employed or we're already employed. And we have pressures from our employers because economic factors, right? Who knows, move fast, break things, right? You don't need to write unit tests. That slows you down. People need to be quick to market. People don't have time to choose what library should be in React, so we grab Next, right? Because like those choices are made for you. Never mind the cost of all of that. It's convenient. That's what we do. This discourages planning and it encourages building large code bases on an unstable foundation, JavaScript. And number 4, and I think it's the most important of them all, is layers of abstraction. Or more importantly, programmers somehow, for some reason, believe that delegation is a separate good. Who likes Docker? Right? And you're okay with the fact that Docker Desktop uses 25% of your CPU. No reason. I mean, like that's competing with Chrome, with Slack, with Microsoft Teams, with VS Code, Visual Studio, everything that's built on top of JavaScript. This talk is not about JavaScript. But What do layers of abstraction mean, right? At the very bottom of this layer, you have hardware, right? Switches and gates on the computer. You don't need to understand this. Maybe if you're lucky and you studied that at vets, maybe. I don't understand it, but I know it exists there. And just above that is what is called machine language, zeros and ones, right? Um, Binary. And above that is something I've highlighted out because it traumatized me in first year. I had to learn assembly. I don't like to talk about it, so we'll skip right over it. And above that, we have high-level languages. So languages like C, Golang, Java, and C# that compile down to machine code, right? To those zeros and ones. And above that, we have interpreted languages like Ruby, PHP, JavaScript. And it's important to understand how these two types of programs work, right? I still have time, right? Cool. The first one is that your compiled languages like C, C++, all of that, what they do is that you write your little code, hopefully you write some unit tests, click compile. Remember, everyone, I'm having coffee because my code is compiling, because software is so bloated and everything is slow. That compiles down to machine code. And what it means is that it's ready to run as machine code. But at the time when something needs to call it, it's already translated. It means that, sure, it won't be as fast as assembly, but it's close enough, but it's ready, right? But how interpreted languages work is that just before it's needed, right? Then it goes and it runs through to in the virtual machine, and that converts it to machine code and response. So think about loading your recipe website. What actually happens is that your browser will request the page, and then there will be some JavaScript that's loaded. And if that JavaScript needs to run, it has to run through a virtual machine, get converted into machine code, and then respond. Yeah, that's why your websites are slow, because that's happening just in time, every single time, right? So we now understand the problem, right? Software is bloated because it can. Software is bloated because of economic factors. Software is bloated because of complexity, and software is bloated because for some reason, developers or programmers or engineers or consultants think that delegation is a separate good, right? We have traded performance for convenience. So, cool, yeah, sure. I thought this was about you creating a website, VT. I'll get there. Cool. Now that we understand the problem, what is the solution? For us to answer this, we need to understand what's at the core of software development or product building, all of that. It's people, right? It's you guys and ChatGPT. But still, you guys, someone still has to ask ChatGPT how to write a for loop. And it's important for us to understand how these people who write software are organized, because you have to communicate. If I'm writing my website by myself, I already know what I think, right? I know what I think about Vue. I know what I think about React, so I can make decisions. I know what I think about for loops and while loops, so I can choose without anyone asking me. I know how I feel about tabs and spaces, right? So I don't have to debate with anyone. But any non-trivial software that is written is organized by a few people, right? Which means that suddenly you have a communication problem, because you might spend some time with your colleague saying that, why did you use tabs? I prefer spaces. And then a whole day goes by, and eventually you guys decide you need a linter that's going to lint the software before it goes up and all of that, those things. But how teams are organized is important. Why? I like laws, right? The original presentation had 3 laws. This one has 3, but the original had 2 different other laws. Only one survived, but this one survived. Conway's law. If you're familiar with Conway's law, Conway says that organizations tend to create clones of their org charts in their software architecture, right? how does that happen? Have you ever gotten a project and you guys were split into small teams and microservice architecture just felt natural? Or have you realized that it's only three of you and you didn't understand the hype behind monolith, right? That's because the way people are organized influences the way that we write our software. It means that it influences the decision that we make. But you find multiple talks about Conway's law, and the original version of this talk was a deep dive into Conway's law and how committees invent and all of those things. And I bored myself practicing. So I rewrote this on Monday. See, the why in Conway's law is more important than the what. It is easy to go around saying that org charts replicate themselves in their software. Actually, it goes beyond that, right? When you have software in a team, every org chart that has ever existed is replicated in the software, right? That's why you have that corner of your code base that you just don't touch, because we had a much bigger team when that was written, and we just don't now. It was 25 before, and now there's only 4 of us. Cool. Then why do I say that the why in Conway is more important than the what? Because the way people are organized means that their communication structures are affected, right? If you have a structure like this as an org chart, it's very difficult for team A to communicate with team X, right? And what do we do when communication is difficult? And communication doesn't mean walking across and talking to a person or going on a phone call. It means pull requests. It means comments on wikis. It means Slack chats and all of those things. But if you can't speak to another teammate in Team X directly via Slack or whatever, it might be geographical location, or it might be someone is sitting on the 3rd floor and you're just not going to use the stairs because it's load shedding and you can't use the lift. It means that you choose what's easy. You choose to replicate some of the functionality into our own team, own it, because what happens is that Conway's law is more about a simple fact. We have high cost areas and we have low cost areas. And if you hire good people, the low cost areas will get optimized eventually at some point. But the high cost areas never get optimized. That's how we ended up with JavaScript frameworks. Frameworks were at a point a solution to a problem that most developers today won't be able to explain to you, right? Because they don't understand what the problem was being solved. I grab Vue, I grab React, I grab Remix or Next or the next thing or the next thing or Bun or Node or Dino or all of these things because I believe that by default, because many other people are using it, then it is good, right? So to recap, the lack of constraints enables software bloat, right? Software is bloating because it can, because our hardware allows it to. But Moore's law is slowing down. It means that these constraints at some point are going to be catching up with us. So you can't just buy a domain, create React app, create Vue app anymore, right? And if you're doing something as trivial as building a website, maybe you can still at some point get away with it because people don't care about vtcodes.dev. That's vtcodes.dev. People don't visit the website. So, you know what? Maybe it's okay if it takes forever to load. No one will notice. No one is looking anyway. But we do work for companies. We do serve real people, right? And our software has an impact on people. We're working in medical fields, we're working in telecoms, we're working in banking. We can't just introduce Next.js because we feel like it anymore. Because the design effort should be organized according to the need for communication in teams. So the next time when you have to build something non-trivial, please consider that. And if, like me, you accidentally start a tech community on Twitter, start a podcast, talk a lot, always have food in the microwave because your wife has gone to sleep and you're busy on Twitter Spaces for 3 hours, but you need a website, maybe grab for good old CSS and HTML and maybe a sprinkle of JavaScript when you eventually need it. Yes, we all don't know CSS, that's why we use Tailwind, but maybe it's okay. And some people might call you radical for that, but it's okay, right? Because it's your website. Thank you.